In the last video, I showed you how I produced a 3D printed model of a planetary gear set for a clock maintaining system. And since then, I've neatened up the files a bit and made something that visually I'd be happy to put the work in and make something out of aluminium. The tolerances of the 3D printed model are quite poor and it's a bit sticky. So I'm hoping that the machined aluminium version will be a lot better. So the rest of this video will demonstrate how I made the aluminium bits, and I'll show you it hopefully functioning properly at the end of the video.
So I'm just cutting the last of the gears for this part of the planetary gear set. I'm doing the sun at the moment. You can see the 3 planets and the planet carrier and the annulus ring support. Next I'll put on some 6mm aluminium and I'll cut the annulus gear.
So there's going to be quite a lot of work cutting the annulus gear, and I decided to cut one out of Perspex first to check the tolerances and make sure there's a good fit before actually committing to cutting it out of aluminium, which is going to take 3 or 4 hours of machining. So in the annulus, the teeth are recessed by 3mm. So I've first cut the 3mm pocket, and now I'm going to cut the teeth, which are deep in that pocket and all the way through, and then I will cut out the ring and that will be the gear done. So I've now finished cutting all the teeth, and as you can see they're recessed and internal, so that was quite a mission. I've drilled 6 location holes around the outside, and I drilled through to the base so that if I need to change the profile of the teeth in any way, take a bit more off them, I can put the wheel back on the CNC and it should locate. And now I'm going to cut the final ring. So that's the final ring cut. I've put a mark on one of the holes, so if I need to put the bit back on the CNC bed, I should be able to locate it in exactly the same position. So I'm just going to finish off with 2 very small chamfers just to smarten the part up, and then I'll take it off the bed with the hot air gun. So I've now machined all the parts for the planetary gearbox, which will supply the maintaining power for the clock. And I thought I'd put it together and show you how it all works. So here I've got the part assembly. I've got the 3 planets rotating around the sun. The sun is physically attached to the arbor of the clock, and the weight barrel is attached to the planetary carrier. And then over the top of this assembly goes the annulus, and over the top of the annulus goes the first wheel of the clock. So I can now simulate the rewind process by turning the sun gear, which shows the action of the planets. And the planets will supply equal torque to the winding of the weight and the driving of the clock. And then when the weight has been rewound, there's a ratchet that holds the sun gear in place, and this is the clock turning, which simulates the unwinding of the weights. So I've remounted the planetary gearbox in the Perspex plates, so I can experiment with its application of torque to the clock wheel. So I'm just going to do a little bit of winding. You can't see the weight in the video going up, but I can assure you it is. And now I'm going to release this stop, and you'll see that the clock wheel wants to unwind. So the next test is to put the spring balance on the clock wheel and see what torque there is, and then apply the winding force and see how much that torque varies. So I've attached this spring balance to one of the teeth on the clock wheel, and I'm going to measure the torque while I'm not winding and compare it to the torque while I am winding. So here we have it in its static state, and it's reading just under 7 grams. So now I'm going to apply a winding force, and we'll see what happens. And it looks like the torque varies by no more than about plus or minus 3/4 of a gram, which should be fine for the clock I'm making, as it's a remontoire powered clock. So as long as that's enough to power the remontoire, we'll be fine. I'm planning to produce some more videos of the clock as it progresses. It's just an idea in my mind at the moment, but it's going to be based on the work of the brilliant 18th century clockmaker John Harrison. So it will feature a grasshopper escapement and a remontoire. It really is going to be designed for hopefully extreme accuracy. I would like to get up to plus or minus 1 second per month. But this may be over-optimistic, but we will find out. Thank you very much for watching if you've made it this far.